Hello, Mr. Kitchen, Global Skill Richmondville High School Physics, and welcome to our introduction to motion. Today we begin with kinematics, which is the study of motion without regard to cause. A little bit later on in the course we'll be studying dynamics, and that's where we start talking about what causes things to change their motion. We'll begin by making a couple definitions, the first of which is a vector quantity. These are quantities with magnitude and direction. They have two parts. Magnitude is just a fancy name for size or amount. So vectors have a number associated with them to give the size, and they have a direction. Therefore, we represent them with arrows. Scalars, on the other hand, are quantities with magnitude only. You're familiar with scalars because these are just the regular numbers that we deal with on an everyday basis. Now here's some vectors and scalars that we can compare a little bit. It turns out that sometimes we'll use a different name for a thing depending on whether it's a vector or a scalar. Distance is one of these quantities. When we say distance in physics, we are talking about the scalar part of it. We're just talking about the number part of it. And to the left, I've got just the letter lowercase d. That's the symbol that we're going to be using for distance. If we're talking about displacement, displacement is the vector. It's how far and in what direction are you from where you started. And the symbol that we'll use for that is the little d, but this time we put an arrow over the top of it, the arrow representing the vector quantity. We have a similar thing with speed, where we use the symbol v for speed, or v with an arrow over top of it for velocity. When we say velocity in physics, we mean speed and direction. And then there are many types of quantities where if they're vector quantities, like acceleration, the symbol for that, lowercase a with the little arrow over top of it. If we want the scalar part of it, if we just want the amount, we're just going to say magnitude of. So magnitude of acceleration or magnitude of force, for example, are the way that we can talk about the scalar parts of those two quantities. Now this is a formula that you're probably familiar with from math. We're talking about average speed here. It's a distance to time ratio. We're going to be measuring it in meters per second. They often call this just rate in math, but we're going to be using the symbol v bar over here. It's just a v with a little line over the top of it, so don't put the vector arrow on top of that v. And when you have a bar on top of something like that, the bar means it's an average quantity. So we would read this as v bar is equal to distance over time, and it's telling us that average speed is the ratio of distance to time. And finally, we're going to finish up with a problem here, a little example. A jet flies about 250 meters per second. They're going from New York City to Rome, which is a distance of a little over 7 million meters. And the question is, how long does it take to get there? Given, well, we're doing a scalar problem. So we're just using d for distance, 7.08 meters. And then the speed that I was given was an average speed of 250 meters per second. You know, the plane certainly goes slower on takeoffs and landing and while it's climbing. But this is a number that we can use to represent the speed over the entire trip. The unknown is time. The equation we're going to use distance over v bar. Put in the numbers. Notice that I've just flipped the units, meters per second, upside down to get rid of that compound fraction. There's no need for the compound fraction. So we can see here that the meters are going to cancel out, and we're just left with seconds. In fact, we have 2.8 seconds to two significant digits. If you divide by 3,600 seconds in an hour, it's about a 7.9 or 8 hour flight to Rome. A little bit more of this coming up in class.